Okay, this is video 7 for chapter 5, goes with section 5.6, and it's all about direct variation, which you'll see is something we've actually talked about a lot already so far in this chapter. So our targets are we can determine if a table, graph, equation, even a story problem, if that relationship is direct variation or shows direct variation. We can write any direct variation equation. So given a table, given a graph, or even a story problem, can you write the equation to go with it? And then, can you describe the meaning of different points on a direct variation graph? So looking at a graph and different coordinate points, XY points on that graph, can you explain what they mean or what they're telling us? Okay. So the first thing is obviously to figure out what direct variation is. Well, direct variation is the same as proportional. If it has direct variation, it's proportional. If it's proportional, it has direct variation. Just another way of saying it. So we can go back and forth, and you'll hear me use both of those terms interchangeably. So let's look at a few different ways we can tell that we have direct variation. So we know proportional relationships have a constant rate. We know we can find the unit rate for them. Okay. We know that they are going to have a constant slope or steepness of the graph. Right? This shows up as a straight line because that slope or the steepness doesn't change. We know that in a table we're going to see equivalent ratios. Right? These are all things we've already covered and talked about. The new term here that we maybe haven't seen before is constant of proportionality. Constant of proportionality. Okay, so these are all the same. The slope, the rate, the constant of proportionality, all the same thing. And we know that we're going to have this if we have direct variation. So let's go through and look at how do we tell if we have direct variation in an equation. Well, your equations for direct variation are always going to be just y equals that rate or that constant of proportionality times x. Okay, the starting value is 0, so we're not even going to write this. That's not going to show up. There's not going to be any adding or subtracting. No starting value here because it's got to be 0. So we're just looking for y equals the rate times x. So when they ask us to write the equation, we're just going to plug the rate in here. If the rate is 7, y equals 7x. If the slope is -9, well, slope is the same as the rate, y equals -9x. If they tell me the constant of proportionality is 4.3, great, y equals 4.3x. So being able to write the equation for any of these proportional or direct variation relationships is kind of what we're getting at in this section. Okay, so let's talk about graphs. Well, graphs are direct variation if, and there's two things here. One, they have to be a straight line. We know that's how we tell it has a constant rate. It's going to show up as a straight line when we graph it. And two, it has to go through the point 0, 0. Has to go through the origin. So let's add origin there. Sometimes you'll see origin as part of your question. You got to know that's the point 0, 0. So let's check each of these. Is this a straight line that goes through 0, 0? Yes. Then it has direct variation. Straight line that goes through the point 0, 0 through the origin? Yes. Then this has direct variation. Straight line through the point 0, 0? Nope. It doesn't go through 0, 0 right here, so it is not direct variation. Okay, and then if it is direct variation, we should be able to write the equation. So I'm going to just quickly remind us, we talked in 5.5 about how to find the slope from a graph, right? Change in y, change in x, change in y over change in x. So this one has a rate or a slope of 4. Well, I can just put that into my equation. Y equals 4x. Change in y, change in x. This one goes up 3 over 2. So that's a slope or a rate of 3 over 2. I can put that into my equation, 3 over 2 with an x. Okay? This one I'm not going to write the equation because it's not proportional. If you need help finding the slope, go back and watch video 6. All right, let's go on to tables. How do we know if a table has direct variation? Well, we already learned how to tell if a table is proportional, right? We know we can check the ratios. It has to have all equivalent ratios. So when I'm looking at these ratios, x to y, x to y, x to y, x to y, they need to be equivalent. I can also check for equal arrows. And I'll show you what I mean. Equal arrows from x to y. So for example, if you notice on this bottom one that, well, not middle one, that this is times 15, times 15, times 15, times 15. That's one way I could check it. And if those arrows all match, then it's going to be direct variation. Okay? If I check this one, check the ratios or divide, look for those arrows, we can see that these are not all proportional, so it's not direct variation. If it is direct variation, like this one was yes, okay, these would all simplify to the same thing. I can write the equation. And again, we already learned to find the rate, y over x. So 45 over 3 gives me a rate of 15. So my equation for this would be y equals 15x. Okay? So we can check if it is direct variation, and if it is, we know how to find the rate. If we have the rate, we know how to plug that rate into the equation. Okay? There's 2 more tables here. I want you to pause, figure out which one is direct variation, and write the equation for it. So pause now and do those last 2 tables here. Okay, this one I checked all my ratios, or I checked all these arrows from x to y. They all match. So I can find my rate, y over x, and I get 10. Nope, sorry, I get 5 for each of these. So y equals 5x would be my equation. Okay, here, these arrows don't match, or these ratios aren't all equal. So my answer is no, and I don't need to be able to write that equation. Okay, on to the back. How about story problems? How do I know if a story problem is going to be direct variation? Well, again, it has to have a constant rate. So that means it's going up or down the same each time. And it also has to start at 0. So it's starting value of 0. Here's a couple examples. Mr. Howerton is ice skating at a rate of 3.7 miles per hour. Write the equation. Well, starting value is just 0, and they're giving me the rate. All I have to do is be able to take this rate and put it in the equation for a proportional relationship. Y equals 3.7 with the x. Okay? Then they ask me, and you'll see this question on quiz and tests, what's x and what's y? Well, I want to go back to this where they labeled the rate, miles per hour. And we know miles divided by hours, miles per hour, means miles over hours. And we also know that the rate is found by y over x. So whatever's on the, y is on the top, so y is miles. And x is on the bottom, so x is hours. This also goes back to dependent and independent variables that we learned in Chapter 3. Okay, number 2. The equation y equals 17x tells the number of French fries for x people. What does the 17 represent? Well, the 17 is the rate, or the constant of proportionality. I just need to write it out with labels. So what does the 17 mean here? Oh, it means 17 French fries per person. Remember, if it's a rate, it's got that word per in it, or 17 French fries for each person. So you've got number 3 and number 4 here. These are just like the ones we just did. Please pause and try those, and then hit play when you're ready to check. Okay, let's look here. They gave me a rate of 6, so I wrote the equation, y equals 6x. Y over x, so it tells me which is x and which is y there. And then 65 is the rate, 65 miles per hour. Okay, so let's go ahead on down to this one. Now I have a double graph with two lines, and we're going to compare. So it says find and interpret the slope. Here we go. Are these proportional? Well, yes, I can tell they're both straight lines through 0, 0, so they are, and that's how I can tell. I'll do friend. Remember, we learned last section, slope is change in y over change in x, or because it's proportional, I can just do y, 28, over x, which is 4, but I need to label these. So the y, second point here, goes with dollars, and the 4 goes with hours. Remember on your graph, these are labeled too if you get confused, x and y. And if I simplify that, I get a rate of $7 per hour. That's something we've already been able to do, right? We could find that rate from a graph, and then I could write the equation, y equals 7x. So I want you to pause and you do your rate and equation, and then we'll talk about who's faster. Okay, so I used a point from my line, the bottom line, to get a rate of $5 an hour. And there's my equation. And who makes money faster? Well, your friend makes $7 an hour, you make $5 an hour. So the friend is obviously making money faster, but it says give two ways that you know. Well, I would say one is that my friend has a steeper line, and also they have a bigger rate. Right? I can look at the line, I can look at the equation, I could look at the rate. It's bigger for the friend. Okay. So I want to take the time we have left, and we're going to get as far as we can, to talk about points on a proportional graph. Here's a proportional graph. It's a straight line through 0, 0. And I want to just label kind of what these points mean. Well, remember this is x, time. This is y, feet, distance in seconds. And so if I have 0, 0, that means I've gone 0 feet in 0 seconds. You can write that down. 2:11. Well, get the labels right. This is 2 seconds. This is 11 feet. So 11, you walk, we're walking, walk 11 feet in 2 seconds. Or we can walk 22 feet in 4 seconds. 4 seconds to walk 22 feet. The key here is that you recognize, okay, this is the y, so it goes with this label. This is the x, so it goes with this label. Okay? Now, we've already looked at how to find the unit rate from here. Y over x, so take either one of those points, doesn't matter, but make sure we can label them correctly. 11 feet to go 2 seconds. 11 feet in 2 seconds, and just actually divide that to get my unit rate. 5.5, right? 11 divided by 2 is 5.5 feet per second. So I can use this point, set up y over x, get a rate, and then I can write the equation. Just plugging in the rate here. Okay. This next part says what point on the graph tells us the unit rate. It is not labeled here, but what you need to recognize is that the unit rate is for 1, right? In 1 second, how far did I go? Well, that unit rate is going to show up in 1 second. I've gone 5.5 feet. So whatever your rate is, the point is just in 1 second, I've gone 5.5 feet. So it's always going to be 1, comma, the rate. Go ahead and write that down. 1, comma, rate is what we're looking for. The unit rate is going to show up at when the x coordinate is 1. In 1 second, how far have I gone? Set up a proportion for these last two and then hit play to check. Okay, check. I set up proportions and cross multiplied.